Hi. Welcome to Math Den, a series of math topics tutorials. This covers algebra, geometry, trigonometry, probability, statistics, calculus, and business mathematics. Today's topic is the process of graphing a rational function. How to graph a rational function. By this time, I assumed that all of you have already known the properties of rational function. If not, watch the following videos first. It defines and illustrates the properties of rational functions. Because, in order to graph a rational function, we need the following: the x-intercept, or intercepts of the function, the y-intercept of the function, the vertical asymptote, or asymptotes of the function, the horizontal asymptote of the function, and the table of signs to determine the behavior of the graph. The x-intercept is located in the x-axis. It can be on the positive and negative value. It can also be one or more, depending on the given function. The y-intercept is located in the y-axis. It can be on the positive or negative value only, because the rational function should only have one y-intercept, or none, depending on the given function. Next, the vertical asymptote is drawn vertically as dashed line. It can be one or more, depending on the given function. Then, the horizontal asymptote is drawn horizontally as dashed line. There should be only one horizontal asymptote, or none, depending on the given function. Lastly, the behavior of the graph on each region will be determined by the table of signs. For example, sketch the graph of this rational function. F of x is equal to x minus 2 over x plus 2. By following the solutions for the properties of rational functions, here are the results. The x-intercept of the function is positive 2. The y-intercept of the function is negative 1. The vertical asymptote of the function is x equals negative 2. The horizontal asymptote of the function is y equals positive 1. After we already placed the properties in the Cartesian plane, the x-axis was divided into 3 regions, with different domain intervals. The first interval is from negative infinity up to negative 2. Negative 2 is not included, because it is a vertical asymptote. The second interval is from negative 2 up to positive 2. Positive 2 is included, because it is an intercept. And the third interval is from positive 2 up to positive infinity. What we need now is the sketch of the graph. Let's construct the table of signs to determine the behavior of the graph on each region. The table of signs should look like this. The first row is for the intervals of domain on each region. The second row is for the test value, which is included on each interval. The third row is for the substitution of test values to the given function. This is to determine the sign of the results, because the sign of the results will determine the behavior of the graph on each region. If the result is positive, the graph will go upward. And if the sign is negative, the graph will go downward. As you can see, substitute negative 3 to the function. The result is negative 5 over negative 1. The result is positive 5, meaning the graph will go upward. Next, substitute positive 1 to the function. the result is -1 over positive 3. The result is -1/3, meaning the graph will go downward. Lastly, substitute positive 3 to the function. The result is +1 over positive 5. The result is +1/5, meaning the graph will go upward. Based on the results from the table of signs, continue sketching the graph of the given function. For the first region, the result is +5. Sketch the graph upward to the right, asymptotic to its nearest vertical asymptote. For the second region, the result is -1/3. Sketch the graph downward to the left, passing through the y-intercept, asymptotic to its nearest vertical asymptote. Lastly, for the third region, the result is +1/5. Sketch the graph upward, asymptotic to its nearest horizontal asymptote. We are done sketching the graph of the given function. F of x is equal to x minus 2 over x plus 2. Complete with its properties, the graph of the given function is shown below. Thanks for watching. See you on the next video. Don't forget to subscribe and hit that notification bell for more video tutorial.